So, in this module we will now go and do a demo of building a XOR gate using NAND gates. Now, we know that this is how the let me assume that the A and B are the inputs and out is the output. Now, let me say this is wire, there is a wire 1 that is coming out of this particular NAND gate G1, this is G2, this is G3. There is a wire that is coming out of this NAND gate G1, this is W1, and there are wires coming out of this NAND gate G2 and G3, let me call it W2, W3 and out. So, this particular circuit now has two inputs A and B, one output. So, two inputs A and B, one output out and three internal wires, namely W1, W2 and W3. Okay. So, let us just basically shrink this, let us keep it in this background, and now let us go and do this particular building of an XOR gate, right. So, let us go back to where we have installed, this is basically the tools, and let us click on this hardware simulator. The hardware simulator comes up, we will minimize this and keep this here side by side, and now let us look at let us go back to this here, let us go to the NAND to Tetris direct, go to projects 01, let us open XOR project 01, let us open XOR.hdl. Let us use it, open, yes. Right. So, let me just explain you this file, there are other assignments that you have to do, but I will just do this here, right. So, now this we have to build an XOR chip, right. This is, so the inputs are A comma B, the output out is out. So, this is how you describe your circuit to the system, right. So, this is a way of describing the hardware. You cannot actually build, you are not actually going to build a hardware per se, but you are going to make a model of the hardware which you simulate, right. So, this is equivalent to the hardware, but this is a simulation of that hardware, right. So, now basically you have to build a XOR gate here, and the inputs are A B and the output is out, and now we have to describe how this code is going to work. So, what you do here, first thing is A is A, B is B, and out is, the output of this is W1. this is nothing but your gate G1 that you see on the other part of your side. Gate G1. Now we will do the next NAND gate, for which your A is A and your B is W1 and your out is W2. This is gate G2. NAND again, A is B actually. For W3, as you see here, your A is B or A is W1, B is B, and your out is W3. This is your gate G3, right? And the last gate NAND, A is W2, B is W3, out equal to out. This is gate G4. Enter. So you have defined your chip, your hardware like this, wherein there is an XR which takes A and B as input, as I am showing you here, A and B as input and out as output. This is capital IN, this is capital out, which whatever is following this capital IN are the inputs A, B. What is following the capital output is the output designated by out. This is the name of your chip called XR. Okay. Now, what you are doing here, NAND A equal to A, B equal to B, out equal to W1, gate G1, A equal to A, B equal to, so what, now we have to put 4 NAND gates here. The syntax that we follow here is that this NAND is pre-built or it is known. You know how to make a NAND gate, we have shown in the course, right. Now, knowing that knowing how to build an AND gate, how will I go and use that to build an XR gate? That is what we are going to see here. Now, this is a syntax. For every NAND gate, there are 2 inputs A, B and there is an output out. How are those 2 inputs connected is what we are saying. For the gate G1, the 2 inputs A and B are this A and B that you see here, and the out is W1, as you see on the other side for the G1. The gate G2 takes A and W1 as an input and gives W2 as an output. Gate G3 takes W1 and B as an input and gives W3 as an output. And the gate 4, which is G4 here, this is G4. The gate G4 basically, as I am showing here, this is G4. The gate G4 basically takes W2 and W3 as input and out as, and gives out as output. So, this is the thing. Now, I save this file. So, this is xr.hdl, we have saved this file. Now, I will quit this. Now, I go back to the hardware simulator and I first load that file. So, I say load chip, and this is in this is in project XR that I am loading it. Now, you see that your entire chip has got loaded. You see this part down here, your entire chip has got loaded. Now, you can give the inputs and see. So, I am giving A and B as input, I am running the program and I am getting 0 as output here. Now, I can give A and A is 0, B is 1, the next input, enter. Now, I can run the program and now you see 1 is the output. Not only you see that, you also see what is the value of W1, W2 and W3 when you apply 0 and 1 as inputs. Now, I am making 1 0 1 and this should become 0, press the enter key and now I run the program, I get 1, 1 0 is 1. Now, I make 1 1, I run the program, I get 0. Not only that, I also get the values of this 0 1 1. So, this whatever you are seeing here is an hardware simulator. Generally, when you design hardware, you cannot actually go to a fabrication unit, make that NAND gate, assemble this and bring. This is not possible, right? In a lab, you can't do this. You don't have a fabrication unit associated with the lab. So, you can just do it on your system itself. So, whatever you are seeing here, the hardware simulator that I am just moving the cursor upon, will actually mimic how the hardware will actually work. So, in this hardware, we have today mimicked the XOR gate. Okay. Now, as a part of this, I give it as an exercise for all of you to basically do OR gate, NOR gate, AND gate and NOT gate itself using NAND. We have already seen how it works and that I give as an assignment for you to do this. Do that, write the code, you go to that directory, the same thing as we had seen here. So, you can write the code here, I just take you back to that directory here, right. So, you can see this or16.hdl, right. Well, this is you can see this not, yeah, you can see this OR, this is the OR gate. You can see the OR, we have done the XOR now, you can see the OR. Similarly, you can see the NOT, right. You can see the OR, you can see the NOT, you can also see the AND, right. Probably there is no NOR, but you please create a NOR file like this. You can create using Notepad and do the NOR also. So, this is left as a first exercise for you. Thank you.